To our class of distributed system. Today we'll be studying about system models. So, what is the purpose and type of system models? First we'll talk about the purpose of the system model, and then we'll talk about the types of system models. So the basic purpose of a system model is to visualize or illustrate or describe some of the common properties and design choices for distributed system in a single descriptive model. So what we here require is that the model should provide the insights of how a distributed system will be deployed, or what all the features it will be utilizing, how it will be communicating and performing tasks, how will it be handling the failures and rest of the issues. So for that we require three type of models. First is our physical model, which defines basically the types of computer and devices along with their interconnectivity. So it's basically related to your hardware specifications and the deployment and the issues related to the deployments. Then we'll talk about the architectural models. So architectural models basically specify how the computation and communication tasks are performed. So they basically deals with the logical aspect of the system models. And third is the fundamental model, which basically presents an abstract in order to describe the solution. Okay, so we will talk about each model in detail in the coming slide. So physical model. A physical model is the representation of an underlying hardware element of a distributed system that abstract away from specific detail of the computer and networking technologies employed. So basically the thing is, physical model is providing you the generalized idea about the computer and network technology employed, but it doesn't give you the specific of the scenario. The thing is that the systems which are being deployed are basically multiple systems which are different in their configurations. That is why we are saying then that the system deploy an increasing varied set of heterogeneity. Basically that means that different systems have different hardware configuration. It is not necessary that all the systems in a distributed system should have the same configuration, and based on network technology and offer a wide variety of applications and services that we all know that we have talked about in the previous lecture, and it may involve up to hundreds of thousands of nodes. So the scalability was never an issue, but handling the effective scalability was, which we have talked about the previous lecture. So architectural model. The architectural model of a system is its structure. uh, Listen again, is it structure in terms of separately specified components and their interrelationships. So basically each component separately and whatever the interrelationship they are holding is specified by the architectural model, and the overall goal of an architectural model is to ensure that the security will meet present and likely the future demand. So the present demand should be met, as well as it should keep in mind what the requirement will be arriving in the future, and it should be able to handle that requirement efficiently. And some other concerns are the reliability of the system, manage manageable. It should be manageable. Like if we add more systems to the distributed system, more system means more nodes to the distributed system. It should be able to manageable. It should be adaptable, and it should be cost effective. So in our architectural model, we will talk about client server model and peer-to-peer model. So client server model. So you must have an idea about client server model, but we'll go through it quickly. So client process interact with individual server process in potentially separate host computers in order to access the shared resources that the server manage. Okay, client just put up a request to the server, and the server simply responds with the outcome of whatever the requirement of the client was. So the client server model offers a direct and a relative simple approach to the sharing of data and other resources, but it scales poorly. Why sharing of data and other resources is simple? Because there is a single host computer or client server which is dealing with all the requests. Okay, why it scales poorly? Because the server is up to an extent can manage the requests of client, but if multiple clients are making the request simultaneously, there will be certain issues. So it scales poorly. Now we'll talk about peer-to-peer architecture. So in peer-to-peer architecture, all of the processes involved in a task or activity play similar roles. Basically, they are assigned the same roles, they have to do the same job, and they are interacting cooperatively as peers without any distinction between the client and server processes or the computers on which they run. So basically what they are doing the same job as other peers are doing, and this is basically they are collaborating and cooperating with each other in order to complete the task. So all participating processes run the same program and offer the same set of interfaces to each other. So basically there is no distinction between one peer or another, that this service will be provided by this peer or that service will be provided by that peer. Basically they all are doing the same thing. So now we'll talk about fundamental model. So as you remember, the key limitation of the distributed system was no global clock. So without the global clock, a system cannot know the time of the other system. So the only way of communication was message passing. But message passing communication over a computer network can be affected by several ways, like the delays they can suffer from or the variety of failure, and moreover it is vulnerable to security attacks. So what we require is we require some model for handling these kind of situations. So for that we require three type of models. First is the interaction model, second is failure model, third is security model. Why we require these three model, we'll talk about in detail in the coming slides, but I know you must be having some idea and you have studied these model in your software engineering or UML, but you must have studied this model earlier, so it will be easier for you to understand why these models are required. Now we will talk about the fundamental models. Fine. So first is the interaction model. So as you are all aware that the only medium of communicating in a distributed system is message passing, and process communicate with messages and coordinate via synchronization and ordering of activities. But the key issue that the interaction model deals with here is the performance, with the difficulty of setting the time limits. So the basic interaction activities of the distributed system are dealt via interaction models. Now we'll talk about failure model. So the distributed system suffer from multiple failures, that can be the failure due to some communication channel or some node failure or some process failure. But what we need to do that how a failure can happen and how we can deal it. So the failure model attempts to give a precise specification of the fault, and that can be exhibited by process and communication channels. So whatever the faults that can happen in a system, the specification of those are provided by the failure models. And now we'll talk about the security model. So as you know that when the resources are distributed, there can be threat of some unauthorized access or some miscellaneous activity. So what security model do? The security model discusses the possible threats to processes and communication channel. So it basically discusses whatever the possible threats are. Furthermore, it introduces a concept of secure channel. So that secure channel is basically an idea which suggests that the secure channel is a channel which is secured from those type of threats, that possible threats that we discussed. With this, we come to the end of this lecture. I would like you to go through the textbook as well, and kindly make sure that if you got any query, you do mail me at utsav@gwca.ac.in. I'll be looking forward for your queries. Please be safe and keep studying. Thank you.